nitrile and carbonyl group are very similar. Now if you see nitrile, nitrogen is more electronegative than carbon. It will have negative charge and carbon will have positive charge. Same thing happens in case of carbonyl compound. Oxygen is more electronegative than carbon, so it will have a negative charge and carbon will have a positive charge. So there is a polarity from carbon to nitrogen side, and here we will have a polarity from carbon to oxygen side. So both bonds are polar. So carbon nitrogen bond as well as carbon oxygen bond are polar. In both cases, carbon has positive charge. So in both cases, carbon has positive charge. This means a nucleophile can attack over the carbon atom. So a nucleophile can attack over the carbon. So if I have nitrile, a nucleophile will attack and this bond will open. Same thing happens in case of carbonyl compound. Nucleophile will attack and this bond will open. Now let us discuss a reaction of Grignard reagent with nitrile. So we have RCN and this is reacting with RMgBr. What will be the product in this reaction? Now Grignard reagent will act as nucleophile because it has negative charge over R and positive charge over magnesium. So first step is nucleophilic attack of Grignard reagent. So Grignard reagent will attack over this carbon and this bond opens. So we will have imine anion formed. So this is imine anion. Now this imine anion in the next step can be protonated to generate imine. So next step is imine formation. So we have imine anion. This can take H plus from water and it will form imine. Now imine can be easily hydrolyzed to ketone. So imine can be hydrolyzed to ketone. So we have this imine. If this reacts with water, it will form ketone plus ammonia. We can also write mechanism for this step. In this step, water acts as a nucleophile. So this will attack, this bond opens. Nitrogen will have a negative charge. Now in the next step, we can lose H plus and the same H plus can be used here. So we will have this molecule. Now finally we can remove one ammonia molecule to generate ketone. So we can remove ammonia and finally we will have a ketone. So this is the hydrolysis of imine. Hydrolysis of imine will give ketone plus ammonia. So we said Grignard reagent can react with nitrile and this will generate ketone upon hydrolysis. This reaction can be used for preparation. For example, if I say how will you prepare this compound using alkyl nitrile. So prepare this compound using nitrile. So you see this CO bond is coming from Cn. So if you see the mechanism, it is clear that this CO bond is coming from nitrile. And another part is coming from Grignard reagent. So we have two options. So we can break from here. In that case, we will have CH3MgBr as the Grignard reagent and CH2CH3Cn as the nitrile. And this upon hydrolysis will generate the desired product. Another possibility we have, we can break from here. That is, so if I break from here, this will be Grignard reagent and this will be nitrile. And this is Grignard reagent. So in this case, we will have CH3Cn plus CH3CH2MgBr. And this upon hydrolysis will give the desired product. So in this reaction we discussed, nitrile can react with Grignard reagent. Initially it will form imine anion that can be hydrolyzed to give ketone.